What I want you guys to do is I want you to write that down. You could title it 3-2 and then the word evaluate. And I've put up a little expression up there, 8b minus 24. And I'm just going to review real quickly so you guys remember what we're doing. 8b minus 24. How many terms does this have right here? How many terms? Raise your fingers. Just tell me how many terms 8b minus 24 has. Everyone should say 2. Okay, the first term is 8b. The second term is negative 24. Good. Some of you are thinking that. But some of you might be thinking in your mind, Mr. A, I'm done talking about terms and like terms and adding or combining like terms. Why can't we just get a simple number from it? And guess what we're doing today? We're going to get those simple numbers. So we're going to use these expressions now to find out what a final version of this expression is with just one number. Okay, do you see the word evaluate? Do you see a word inside of that? Value. I'm trying to find what's the value of this right here, but I'm missing something. I need one thing in order to find that value. What is it? What's that one thing? Yes, sir.
You need to know what B is.
I need to know what B equals. And so in this problem, B is going to equal 3. Okay, B equals 3. Now, before you start doing anything, I want to know what this is worth. That's what it means by evaluate. What's this worth? And I just told you that B equals 3. So what we're going to do is we're going to justify what our evaluation is. So evaluation happens a lot, by the way. You guys got evaluated on your tests. You remember that little percentage up there? That's an evaluation. You understood 80% of the material. You understood 93% of the material. You understand 100% of the material. Or whatever. So that's an evaluation. I get evaluated. Mr. A, you're on time or not. You turn in your lesson plans on time or not. You are instructing most of the time or not. So they're evaluating me. They're finding the value of what I'm doing. So they have to justify it. My administrator does not come to me one day and say, you know what? You are doing a fair job by. And I'm like, oh, cool, fair. That's not good, but it's fair. It's not poor, but it's still fair. And as he walks out, wait, how'd you get that? And he walks away. How'd you get that evaluation? What does he do probably after he tells me I've done a fair job? What do you think he might do? Yep.
Evaluate you while you're teaching classes.
Yeah, he might watch me. He might look at my lesson plans. He tells me why he said fair. Because if he didn't tell me why he said fair, I'm like, is it my haircut? Is it because I like wearing polos? Is it because I use swivel? Are you using swivel against me? I don't know why you're evaluating me. So he tells me, and that's what we're going to do here. Okay, this is what I want you to do on this problem. You're going to do 8, and you're going to use this first property. Instead of B, what are you going to put? 3. You're going to substitute 3 for B. So that's what you substituted with. Okay, now order of operations, what would you have to do first in this problem? Okay, parentheses, you're like, all right, is there anything to do within the parentheses? No. So then you go exponents, that's done. And then you go left to right, multiply or divide. So what do we have first? 8 times 3, and that gives me 24. And then I still have this minus 24. So 24 minus 24? 0. And then I end up with my answer. That's what this expression is worth when B equals 3. That's what it means. That's it. So you like your numbers, right? Here's your number, 0. That's it. Now, is this expression always going to be worth 0?
No.
No, it depends on what B is, right? So that's something you need to understand. In this case, it does equal 0 because B equals 3. Yes, ma'am?
So are we just doing solving problem with
No solving, just evaluate. And you're like, wait. So, Sammy, on Monday you're going to start solving. On Monday I'm going to say, all right, I have, sneak peek, I have an equation. What does the variable equal? You're going to have to tell me what that number is. I already told you what that number is, so there's no solving to do. You're just evaluating. I know.
Different?
One is you don't know the variable. The other one, you do know the variable. In this case, I do know the variable, so I'm not solving for anything. Like it's not a mystery what the variables are. Okay, here's your second expression. 6r squared minus 4t. Okay, that's your second expression. And I said that r equals 10 and t equals 3.5, okay? You are not just going to give me the final number and say, yeah, I got it. You're going to justify it for me. You're going to prove to me that what you say is the actual number. So all you have to do is say 6 times r squared, okay? 6 times r squared minus 4t. Now, what did I put instead of the variables? What did I put instead of those variables? I put a set of parentheses, right? And so what should I put in for r?
10.
10. What should I put in for t?
3.5.
So that's all I did. That's my problem now. So according to order of operations, Reese, is that a hand up?
Yeah.
Question, go ahead.
What's the problem that we did like the in class yesterday?
Oh yeah, we need to get to that. We'll still get to that. Save it for that. Sorry, Reese. Thank you for bringing that up. What do I have to do to make this simple? First step, Henry, what do you think?
Would you multiply within the parentheses?
Okay, yeah, so I'm like, all right, 10, but there's nothing in there. So there's just 10 and then just 3.5. So what's my next step? So I'm done with parentheses. I go to exponents. So I got to deal with this right here. So what's 10 squared?
100.
Ooh.
100.
Yeah, it's 10 times 10. So 6 times 100 now, minus 4 times 3.5. Okay. Now I'm done with my exponents. I was already done with my parentheses. Now I do left to right, multiplication or division. So what would I do next?
6 times 100.
6 times 100 and negative 4 times 3.5. All right, what's 6 times 100?
600.
Awesome. And then what's negative 4 times 3.5?
Negative 1. Positive 4. Negative
Okay,
4.
some of you are getting really close. I'm going to do this. I'm going to do 3.5 times 4.
Oh, 14.
Mm-hmm.
Oh, I didn't do that.
Because that little decimal point. And it's negative 14, right? Because it was negative times a positive is negative. So 14. Now notice, I called that a negative. And now I'm going to call it a minus sign. And that's okay. Six.
It's easier.
It's just cool to do, right? You can call me. So again, I'm called Mr. A to you guys. Some of my fellow teachers call me Mr. Alcocer. A different name, but same person. And my wife and other people call me my first name. Still me, but it's just a way for different people to communicate. So it's like that. Is that a negative sign? Yeah. Is that a minus sign? Yep. Is it opposite of sign?
That doesn't
Yes.
make sense to me.
Awesome. Thank you.
Because, like, how can you just, like, change it all around? Like, 1 second it's a negative, next second it's a minus sign. Like, how do you know when to change?
If you want to call it, if you want to still call it negative, you can. You can call it negative. So we'll say it's 600 plus negative 14, right? You can still call it that. That's the justification.
586.
I mean, you'll get used to it, Caroline, because I'm speaking a new language for some of you guys, and that's okay. And it takes longer to get that down. 600 minus 14, though?
586.
586. 586. Okay, now listen to me. I know some of you can get to that answer pretty quickly without showing your justification, but you're going to show me your justification. So you're going to show me work to get to that. I know, it's amazing. Do you guys remember my work that I showed you guys? So last night I did more math, and tonight I'm going to do more math, and then Saturday I'm going to do more math. And I'll tell you this right now. So here's what happened. I turned in a homework assignment last night, okay, probably like 8 o'clock. Turned it in. I got the grade this morning. I got out of 5 points. I got 4. I was so like, what happened? I looked at it, I'm like, sad. Because 4 out of 5 is 80%. 1 point, 80% is what my score is. So I'm like, what? I missed one thing. So here's what I missed. I showed all my work, and he said, all your work was great. You had the right answer, but when you wrote your answer down, you wrote it down incorrectly. I'm like, and I looked at it, and he took off 20% of my grade for that assignment. And you know what? Who does that?
You do.
You do that.
I take that and I'm fine doing it. So listen, I get it too. I get that same standard, but by the way, I don't take 20% off your homework if you miss, if you do the wrong answer, even though you had it in your work. I take 1 point, which is like 1% of your 1% of your grade, maybe
But not if we
1%.
have 5 problems.
Well, yeah, and you don't have 5 problems usually, so that thankfully works out. So 5 problems, I missed one, I got 80%, and then I look at it, I'm like, yep, I did it, I deserve that. So your teacher also gets graded a little bit stricter, and I'm fine with it because I did make the mistake. I had the work, and I was almost going to say, man, but I had the work, it's right there, but I said it incorrectly. You may have the answer, but I want the work that justifies the answer. I can just say the answer and say, well, where'd you get that answer? From my friend, he told me. From the calculator, it showed me. From online, I put it in, it just popped up. Yeah, I need the justification, so you're going to do that. No questions about that. Any questions about the actual work, like what happened here? Yes, Mary Allison.
So with 4 times 3.5, couldn't you just use the distributive property and said 4 times 5 is 20, so add a decimal, and that's 2, and then 4 times 3 is 3. It's
12.
And you add a negative sign.
Yeah, you could have said 4 times 3. Well, you did do that actually, even when you did this way. But 4 times 3 is 12, so keep that number. And 4 times 0.5 is 2, and 2 plus 12 is 14. Yeah, so you are, and you have been using the distributive property ever since you learned this method.
And then are we allowed
So you do love it.
Take it to a small number, or if it's like 4 times 3?
Oh, you didn't have to. Sorry, you didn't have to show this.
Okay,
No, I said that because some of you were like, wait, you're giving me like different numbers, but just work it out. If you're confused, get it. But you could have gone directly here. That's okay. Yes, I think I see your question. Okay, now I want you guys to do this one on your own. Find the value of this expression given those values for the variables. So you find out the value. And please justify your work, your answer, because if you get it wrong, I could see what you did wrong. If you don't show me what you did, I'm like, did you guess wrong? I don't know.
Is the negative already there, or would it be like minus then negative?
So
Would there be 2 symbols there, or just 1?
you need to do exactly like I did the other ones, and you'll be fine. It'll be very clear. This is what was happening.
Do not.
Do you have it written down for the other ones?
Maybe somewhere.
Yeah, so I'd find that because that's going to help you. Still looking for someone to have that work the way we talked about it. It's getting there. That's very close.
So for this, when you do the negative 4, you do like 20 plus positive 10?
Yes, that's what you would have to do. Yeah, I like that. Did you write that?
Yeah.
Good. I don't know. I didn't look at the answer. I'm looking at the work. Okay, here's what I'm seeing here. This is what you do first. All right. I'm going to write the problem down, but instead of the variables, what do you think I'm going to put? Parentheses. So I'm just going to put parentheses. Because when I do that, I keep everything very clear. Okay, you're like, what? You just got rid of the variables. Well, what's in place of x? Or what should be in place of x? 20. What should be in place of y? That's super clear now. Okay. I have to do what's in the parentheses first. So I got to look in here. And then what's 20 minus negative 4? It's the same thing as 20 plus positive 4. So it's 24. And then 3 times 24 divided by 8 is my actual problem. How many of you got 16 over here? 16 when you did that? You got 16? Okay, this is what happened. You forgot your parentheses. You just said 20 minus 4, right? Yeah. But it's 20 minus negative 4.
20 minus 4.
20 minus negative 4 is 20 plus positive 4. That's 24. So you got to make sure you keep that straight because then it throws it off. Now, when we do this one, let me finish this off. Okay, how many of you did 3 times 24? Okay, you figured that out. Well, why don't you use your different properties and procedures? I got a 24 and an 8. What can I do with those two?
Oh, you can
I can simplify them. What's 24 over 8? 3 over 1. What's your final answer? Should be a 9. If you did 3 times 24, oh my. That's interesting.
We did it right before you told us the answer.
Okay. 3 times 24 is 72, and 72 divided by 8 is still 9.
I did
Still
3
9.
times 24 and it wasn't that.
It should be 72.
Yeah. And then 72 divided by 8
It's 9.
is 9.
I did that.
Good. Did you get 9?
Yeah.
Good.
I don't know.
Not sure, but you're testing me and I get it. I think I passed that one. All right, Jimbo, go ahead.
I misread the number, so I put 78 over 8, and then I got 9 3/4, so I started drawing a picture of Harry Potter.
Gotcha. All right, Kaden.
So I didn't see, I forgot that we're supposed to do the negatives, and I remembered that you could just do the subtracting sign as the negative sign.
Gotcha.
So
Okay.
that's what I did.
Yeah, so remember, guys, this is what was going to throw a lot of people out. If you got 16, that's exactly what I was trying to avoid. You put 20 minus -4, which is really 20 plus 4, and then you get your 24 there. If you got 16, it's because you just did 20 minus 4. But what is x equal?
20.
What's y equal?
Negative.
So it's 20 minus that, which is really 20 plus 4. So be careful of that. And Sammy, go ahead.
Okay, so so I did it like in the wrong operation. So,
Oh, okay.
but for 20 minus -4, that did
Say
not,
420? What?
20 minus -4. How did that become?
Ready? 20 minus -4, right? You're saying that?
Yeah.
Stay, change, opposite.
Okay, I get that, but like, why do you do it?
That goes back to our definition of subtraction. That subtracting is the same thing as adding the opposite. It's just a definition. And it always works.
I don't get it.
That's all right. We'll keep
It's
practicing.
like in English, when you have a double negative, you have to
Yes, Mary Hanson. And then I'm on.
I am. Wait, why did we just move on to 3-3?
Because we're done with 3-2. You were saying we were taking too long on 3-2. We're done.
Yes, we were, but still.
We're done. I would be happy.
I'm confused somehow, like, I thought we already did order of operations.
Yes, but order of operations doesn't go away. We keep doing it over and over.
I think
It's still what? Sorry. I'm confused now.
I'm
so confused, Marianne.
You're confusing
because
us.
we did a whole unit on it.
Yeah,
Then
now
we're
we're
like,
applying it to this unit.
So yeah, everything we learned in previous lessons, we got to keep applying them to future. That's why it builds upon itself. But let's keep going here. We are now on 3-3, and we're going to finish that in the next few minutes because the book does go over a lot more than what I'm going to cover, but I'm going to cover that next year, so I'm not too worried about it. Okay, equations. You've heard of equations before. Equations always have a certain symbol. What's that symbol?
Quotation mark.
Not quotation mark. I put that for whatever fits in there. Yes, ma'am?
An equal sign.
It's an equal sign. It has an equal sign. All of them. They all have equal signs. So some people are like, yeah, I get that. Yep, that's it. And then I ask you, is this an equation? And you're like, yeah, it is. But where's the equal sign? Equations have to have equal sign. Please don't forget that. Like I'm going to test you in just a few minutes if you really understood what I said there. Yes, sir?
Does that mean if it doesn't have an equal sign, you're simplifying?
Yeah, you could say that way. If it doesn't have an equal sign, you're simplifying or evaluating. If it does have an equal sign, you're more than likely solving, but not always. I'll show you why. Okay, always have equal signs. Okay, and then I'm going to use this word a lot in this chapter, the word balanced. I'm always going to say balanced. Okay, I think of like a balance beam. Like in science, you have those balance beams. I remember all the way back in like first grade doing like balance beams, putting something on this side, trying to balance it with that side, and my little first grade mind just couldn't figure out why I kept going back and forth. Well, now we're going to get balanced sides every time. Okay? That's what equal sign means. Okay, so you always got to have an equal sign, and here's a little illustration. You're going to have, for the most part, two sides. You could have more equal signs, but for us, our purposes, we're just going to have an equal sign. You're going to have two sides. You know what you're going to have on the left side? You're going to have an expression. Remember, we talked about expressions. You know we're going to have on You know what you're going to have on the right side? Another expression. And those two expressions have to be equal to one another for it to be true. So here's what I want you to do. If you have two sides here, and we set equal signs in between, then I think of this as a balance beam. You're going to have two sides that are balanced. So you guys remember that? You guys remember that little simple balance? There you go. I think I saw him in Mr. Withers' room. He has those balance beams. That's what you're doing. Okay, whatever's on this side has to stay balanced with whatever's that side. If not, this is what happens. It was balanced, then you added too much to one side, or you took away from this side, whatever the case is. You want to keep it balanced. I will continue to mention that over and over again this whole chapter. So we'll keep working on that as we move on. Starting Monday, really, with that idea. Yes?
So you know those, I forgot what it's called, but like
Me too.
when you do like the, like 3 is like equal to like something or something. You know how it could be like 3 is equal to 3 times 1, and you put like an equal sign in the middle? Would that be an equation?
Yeah, if you have an equal sign, equation. Yep. And so guess what? We already dealt with an equation. That's one. That's one. Okay, let's look at this first one. Write this down while you guys are asking questions. Write that down. I'll go with Stella back there.
Is this the thing where you have the equal sign and then you have like
Yep.
the pawns? Like whatever those things are, and then like one of them represents X, and then you have what that is?
Nope. I do know pawns, but I don't know.
Just do it, but that's not equal
And then you
to
have
11.
What's that
No,
called?
they are equal. Okay, hold on. Sorry, Stella, that's a great one to ask when we're doing homework, I think. Let's get this down. But I'm curious about pawns. Okay, here's what I want you to do. I want you, and I'll get yours, Ruth. Is it on this problem or the last one? Or just kind of in general?
Like general.
Can you say that real quick? Okay. Guys, I have an equation here. Why do I have an equation? Like, how do I know it's an equation? Go.
Equal sign.
Equal sign. Please just remember that. And that means I have two sides. I have this left side and this right side, okay? Sometimes one's more complicated than the other. Sometimes they're both complicated. Sometimes they're both simple. In this case, a little more complicated, pretty simple. Okay, on my balance beam I have 2p minus 5 and 11, and they're balanced up. They're balanced with each other. That's all I'm saying. That's all I'm trying to say right now. Okay, now what I'm trying to do is going to look a lot like what we just did in 3-2. I said if p equals 5. That means if I substitute 5 for p, is this a true or false equation? Don't say it. Don't say what it is. All right, what I'm going to do is I'm going to put it in just like I did in the last lesson. Notice that they're very similar, these two lessons. All right, so here's what I put in for the left side. I just did the left side. What's 2 times 5? 10 minus 5?
5.
Okay, so I have this right here. I have 5. Okay, can I make 11 any simpler?
No.
Are these two equal?
No.
So this is a false statement. This is a false equation. That's all you're going to put. That's your answer, false. In fact, that's kind of what I did on my homework. All that blah, 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 blah. True or false is what my answer was. But my teacher didn't want just true and false. Rightly so, because it's a guessing game. Flip the coin. True, and you got it right. Awesome. Flip the coin. False. You got it wrong. No, I need justification, and that is false because of this. So that's what you're doing on this part of the assignment. You're just telling me true or false, but you have to show me why. Don't just give me true or false. I'm not taking it. Yes?
Is this what we're doing on homework?
Yeah, that's what you're doing. All right, let's do another one. You're just seeing if you substitute p for 5 for p, is this going to be true or false? All right, go ahead and do this one real quick here. So you got this is an equation because it has an equal sign. You might find that one. Or leave it in that. Yeah. So this is an equal sign right here. This is an equation. It has two sides. Those two. Both sides are expressions. So x squared is an expression. 16 is an expression. Okay. So here's what I'm going to do, and I hope you did the same. I'm going to put parentheses for x squared, and that's negative 4. And then 16 is just 16. There's nothing to do there. Okay. What's negative 4 squared? 16. 16, because it's negative 4 times negative 4. That's positive 16. And that's a true statement. That's a true equation.
Oh, I thought the equation was x equals negative 4, so I didn't like that.
No. So that is, but yeah, it'd be harder to put it back in there. Okay, yeah, so they'll give you the equation first, then what the variable or variables equal. How many of you put true? Okay, did anyone put negative 16 on accident? Like you said, negative 16 equals 16. Do you see how it got tricky there? But if I do this parenthesis, what's a negative times a negative?
Positive.
So it's very easy to know. It should have been, positive 16. Don't forget those parentheses. Yes.
What if they're both negative? Or
Both.
Is that even possible?
This right here, like if this were negative, it could have said negative. Then it would have come out false.
Yeah.
But you could do it, or they could both come out negative if it did something like that, and then that would have been true. But not in this problem necessarily. All right, here we go. Next one. Go ahead and do this one. A simpler equation, I hope. Justify it though. I don't want just an answer. That's not enough. You're not proving anything when you just say the answer. You just got it from the answer key. You asked your friend. You put it in your calculator. No. You got to give me,
X equals negative. Oh, I thought you meant on our phone.
Stella? Question or you have an answer? Okay. Did you do this? I hope you did. Because this will help you to get it. Okay, I put 4 minus, in parentheses I should put negative 4. Okay, that means that's important. What's 4 minus negative 4? It's the same thing as 4 plus 4.
8.
It's 8. Does 8 equal 0? No. That's false. And if anyone wants to argue that 4 minus negative 4 equals 0, we could do that all day. But it's not. 4 minus negative 4 is 8. And 8 does not equal 0. That's false. How many of you got false? Got false, okay? How many of you were careful not to put 4 minus 4? That's easy to, 4 minus 4 is 0, but that's not what it was saying. Be careful. Those negative signs mean something. Yes, ma'am?
It's like in English, if you have a double negative, like I can't not have the truth.
Oh,
so
yeah.
That means you can have the truth.
And even on those, when we say can't not, don't we try to correct that? And we say I can have. So we do the same thing because that's hard to think of. All right. Ultimate last one. If you could do this one, we're good to go with the homework already.
11:40.
It's 11:40? Okay, cool. We have a lot of time.
Yay, lot of time for work.
All right, but go ahead, get this right, guys. Everyone's working it out. No. Everyone's working it out on your paper. You got to justify it. So I need to see work, and that's what I'm expecting on your homework. And these problems are not like super in depth, but I do need to see those steps that you took. Yes.
Is this justified?
Yes, but then you worked that out. Like,
I did.
you do this times this?
Yeah, I have that down there. 12 equals 12. Like, that equals 12.
No. Like, what? How did you get 12 from there? That's what I'm looking for. Like,
I know.
What's the
That's what I meant.
intermediate
This
step?
is the equal. That's not the equation. That's what that
No.
equals.
I get. Yeah, but how did you say from here to here?
What?
Like, how did you go from this to this? Like,
3/4 times 16 equals 12.
yeah, how did you do that?
So I need to write that up there. Like,
No, write it kind of underneath. Yeah, right there. Perfect, right there. Yep.
And I have a question.
Yes, sir.
So when I was out visiting my foot, I turned in some homework like a day or two late. It still says it's missing.
Yeah, because my homework is to put in all your homework in there, like everyone's homework. So I have to still input it into the system, which I'm going to do today.
Oh, it's not facts. It still says it's missing.
Yeah, you're good. And I talked to your mom yesterday. I said he should be good. Okay, yes.
Can I do it?
Yeah, tell me what to do. Stay quiet. Go ahead.
So you need to change. You need to rewrite the formula as 3/4 times 6/1.
A 16 over 1? Okay, I could do that.
16 over 1. Okay. And then
Okay.
you can multiply that, and then you can X out the 16 and 6 and 4 and 1 and then 12 and 1.
All right, how many of you got true? True's your answer.
I did.
Good. That's what you're supposed to get. And that's look. This is the problem they give to you, so you don't have to rewrite this on your paper. I do it so you can see what we're doing. This is what you're doing. That's what you get. Then you're done. That's all you do. And you're going to do that for a few problems on equations. So listen. Put in parentheses for the variables, then simplify it. If you try to do it kind of quickly or whatever, you're going to mess things up, especially with negatives. So please be careful with that. Chris, last question.
So I got true, but I got different numbers.
Oh, okay. Yeah, so
I got 3 equals 3.
let me look at it. I'll look at it in just a moment. All right, go ahead and do this, guys. It's not two separate assignments. It's like part of one, part of another, and you're just doing it on the same paper. So please write that down. It's a lot. Do it first, then tell me if it's a lot or not.
I bet it's not a lot.
It's not.
Sorry.
Can I help? Sorry, Chris, real quick, and then, sorry, about that one, Chris.
Oh, well, so I got 3 and 3. I did like 3 and 4, and then I put the parentheses, but I didn't put those in one. I did 4, and 16, and I did.
But you also canceled this out, right?
Yeah, and I did 4 and 12, and now I did 3.
Okay, only do it on one side, so you would do that separately. So you do what you were doing, but then this is its own thing. Can I see pencil real quick? So if you canceled this 4 and that 16, that would have left you a 4 here. So you got 12 and 12.
Wait,
So you don't mess with this.
what about
This 4? So 4 and 16 cancel.